When we study motion, usually we start by learning about motion in one dimension. Once we have a good understanding of the kinematics, the relationship between the motion variables in one dimension, then we can move to 2 dimensions or 3 dimensions. Very well. So now, when we try to study motion, the first thing we need to learn about is the displacement vector. Displacement is a vector quantity. That is to say, it has both magnitude and direction. On the other hand, distance is a scalar. Distance is a scalar. Distance doesn't have direction. You are just thinking about how long was the distance, the displacement. While displacement, you need to tell about the magnitude and the direction. So the first vector that we need to learn about when we start learning about motion is the displacement vector. As you can see here, we have motion along one direction, the x direction. And here we have this object, this car, moving from point A to point B. Okay? So the car here moves to the right from position A to position B. The change in position, which we call displacement, delta x, equals x final minus x initial. And the unit for the displacement in the SI system, the SI system is the international system of unit that is accepted by the scientific community wherever you go. The SI unit is meter for displacement, and also for distance, it is the same unit, meter. Okay? So here, the displacement x final, say 52 meter, x initial, say 30 meter. So the displacement 52 minus 30, it is 22 meter, and it is along the positive x-axis. So the magnitude is 22 meter. The direction is along the positive x-axis, that is, say, to the right. Okay? Then consider this situation. The initial position was 38 meter. The final position was minus 53 meter. So the car is moving backward. Again, we use the same formula. Delta x is x final minus x initial. X final is labeled minus 53 minus x initial 38. So the total displacement is minus 91 meter. Okay, so the magnitude is 91 and the direction is to the left. Displacement can be in any rate. It can occur at any rate. So here, if you take the x-axis for the displacement, you have the value of x here, and here you have the time values, the change in time. So at time 0, at the initial point, the car was at point A. After 10 seconds, it is at point B. After another 10 seconds, it is at point C. After another 10 seconds, it is at point D. Then at 40 seconds, at point E. Finally, at 50 seconds, it is at point F. So you can see that the position is changing with time. The position is changing with time. This leads us, whenever you have change in the displacement with time, this leads us to introduce another vector which we will need to describe the motion, which is the velocity vector. We define the average speed as the path length divided by the elapsed time. The path length divided by the elapsed time. This is speed. And since we are talking about a path length, long path length, and long elapsed time, so this is an average value. To calculate the value, you need to divide the distance d by the time t. For example, if you drive your car from Atlanta to St. Petersburg, the distance is 500 miles. It took you 10 hours. The average speed is 500 miles, that is the distance, divided by the elapsed time, 10 hours. So the average speed is 50 miles per hour. Now here, I want you to take note that we are talking about speed. Speed is a scalar, it is not a vector. We don't need vector information. So we don't know exactly the direction that the car was moving through these 10 hours, and we don't care because we are talking about speed, not velocity. But we need to know the speed, which is the rate change of the distance. 500 miles divided by 10 hours, this is 50 miles per hour. This is the speed. Side trip to Jacksonville, the 600 mile, the time 10 hours, so the average speed 600 miles divided by 10 hours is 60 miles per hour. So we know now this game, we know how to calculate the speed. Okay? So here, to calculate the distance, you need the final position minus the initial position. To calculate the change in the time, the elapsed time, you need the final time minus the initial time. And the SI unit for the speed or average speed is meter per second. Meter for x and second for the time. So here a few examples to illustrate what we are talking about. In 10 seconds, the car moved from x initial 30 to x final 52. So the elapsed time from 0 to 10, this is the elapsed time, and the change in the distance, 52 minus 30. So you have 22 divided by 10. This is 2.2 meter per second. This is the average speed. So sometimes we have situations where velocities are equal, but speeds are different. Okay? Consider this example. This is a nice and interesting example. The figure, this figure here, shows the unusual path of a confused football player. After receiving a kickoff at his own goal, he runs downfield to within inches of a touchdown, then reverses direction and races back until he is tackled at the exact location where he first caught the ball. During this run, which took 25 seconds, what is the path length he travels? What is the path length that he travels? So you can see here, it's labeled 0 yard, and the other end is labeled 200 yard. What can you say about the path length? I'd like to hear you. Any suggestion?
yards.
Thank you. Yes, it is 200 yards. 100 yards this way and another 100 yards that way. Together, it is 200 yards. Thank you. Now, what was the displacement? So the distance was 200 yards. The distance was 200 yards. Now, the displacement. What is the player's displacement?
Zero.
Yes, thank you. The displacement is zero because displacement cares only about the initial and final positions. So here x initial and x final are the same. X final minus x initial, the displacement is zero. Okay? So this is a nice example to show that displacement is different from distance. Displacement is a vectoric quantity. In this case, it is zero. Okay, you have 200 this way, 200 in the other way. The two vectors cancel each other. They have opposite directions and the same magnitude, so they add up to zero. While the distance, it is 100 plus 100. The distance was 200 yards. So I hope now we understand the difference between distance and displacement. During the player's run, which took 25 seconds, what is his average velocity in the x direction? What would you say? I will give you a tip.
Is it 3?
Velocity, it is what, sorry?
Is it 8 yards per second?
Okay, I will leave it here and go back to my tip, then I will let you revise your answer. Velocity is derived from displacement. Velocity equals displacement divided by time, while speed is derived from distance divided by time. So here, if you want the average velocity, you need the average displacement or the total displacement, and you need to divide that by time. What was the displacement here?
It was 0. So it would be 0.
So if you divide, precisely, thank you. If you divide the displacement by the elapsed time, displacement is 0, so the average velocity is 0. Now, if I ask you about the speed, what would be the average speed, then that would be your answer. The average speed, you take the total distance, which is 200 yards, divide that by the total time, 25, so the answer is 8 yards per second. Okay? So now we understand the difference between speed and velocity. We understand the difference between distance and displacement. This is very important. These are fundamental but very important concepts that we need to understand well. Okay? Any question about these concepts? We are good?
Yes.
Very well. So in general, we can calculate the average speed, the average velocity numerically. We can also do the calculation graphically. So here, if you graph the relationship between x and t, it is a linear relationship. This is a linear graph. And the slope, as you know from mathematics, slope is defined as the rise divided by the run. The rise is the change in x, and the run is the change in time. So it is delta x divided by delta t. So from the slope here, we get the average value for the velocity, also for the speed. The difference, if it is velocity, you'll be talking vectors, you'll be talking displacement. If it is speed, you'll be talking distance, which is a scalar quantity. So the average velocity between any 2 points equals the slope of the blue line. So here we don't care about the details of the path. We only care about the initial and final position, because the displacement is determined by these initial and final positions. Okay? So in general, the average velocity is equal to the slope of the straight line joining the initial and final positions on a position versus time graph. Okay, so here, for example, if you want to take between A and D, this is the initial, this is the final. So the change in x from this point to that point, you have 30 meters, and the change in time from here to here is 30 seconds. You divide 30 meters by 30 seconds, so it would be 1 meter per second, and so on and so forth. If you take between E and A here, for E, the displacement is minus 37 meters, and for minus 30, I think this equation is not right. We need minus 30, that is the position for A, that is positive, not negative. Anyway, here the assumption is that A is somewhere here, minus 37 and minus 30. So E is minus 37 and A assumed to be at minus 30. We don't see it on the graph. So you just imagine that we have A here at minus 30. So it would be minus 37 minus 30. This equation is not right, I apologize. Many of the slides sometimes contain information that is not right. So we have here to correct this equation. So yeah, this is a picture, I cannot write it. I will do that after class. When I post I will repost the slides on Blackboard. I don't want to confuse you with this. You need to apply this equation. You know xf, you know xi, and you just plug in that is there. Okay? So we move on to another concept, which is the instantaneous velocity. The difference between average velocity and instantaneous velocity is that average velocity is taken over the whole motion, the whole change, the whole displacement, whole change in position, and whole change in time. While instantaneous velocity, we mean the velocity at one instant of time. One instant of time. Because of that, we call it instantaneous velocity. So to calculate the instantaneous velocity, you need delta t to go to 0. Delta t limit as it goes 0. Okay? when the change in time is very small, very minute, then the average velocity becomes instantaneous velocity. Very well. Here we have some data for the instantaneous velocity. So when t was 1 second, x was 5. When t 1.01, you see just slight change in time. Now it is 5.47. When t is 1.1 second, now it is 9.67, and so on and so forth. There is irregular change in the values of x with time. This is how the instantaneous velocity changes. While for the average, you take long time interval, like from 1 to 3 seconds, the change in time 2, the change in position 47.5, and the average velocity or average speed is 23.8 meter per second. So now we understand the difference between instantaneous velocity and average velocity. Okay, for example, here, this is for the average velocity. Okay, while for the instantaneous velocity, you take the slope. So if I want to go here, for example, if you take from 1 to 1.01, this is infinitesimal change in time. The distance changed by 0.47, divide that by the change in time, which was very small, 0.01. So it is 47.0. Although this is average velocity, but because the time interval is so small, we can look at it as an instantaneous velocity. In general, instantaneous velocity is taken as the slope of the curve. The curve represents the motion, while the slope will always be just a tangent, just a straight line. Okay? So now we understand these two concepts, average velocity and instantaneous velocity. Any question about these two concepts? You need just to consider t to be very small when you think of instantaneous velocity. If t is taking over two distinct positions to distinct period of time, then you are talking average values, not instantaneous values. Very well. So here the instantaneous velocity is 15 meters per second. The slope is positive. The slope can also be negative. If it is negative, then the instantaneous velocity will be negative. In both cases, the speed is 15 meters per second.